I'm Mark, one of the technical team here at StorMagic, and what I'm going to do is an end-to-end build process of two systems running Windows, Hyper-V, and creating a failover cluster between the two using our SvSAN virtual SAN software to provide the shared storage. As part of this, I'm going to be working nested. I'm going to show you a little bit of the internals as how we do our internal labs here at StorMagic as well. So just to run through really quick with some diagrams as to what we're effectively looking to build out. Let's make that a little bit more sensible. So what I have then is, or what we'll build is a concept of some boot storage, some cache, and then a capacity tier. Now, the reason I'm doing this is obviously you do away with the cache. It's simpler. And having the separate boot storage is obviously, nice and straightforward. Now, I think everybody knows with SvSAN, we're providing this network RAID 1 synchronous mirror of the storage. We tend to recommend having some internal resiliency through hardware RAID or software RAID of the drives themselves as well. Okay, so think fault domains, think edge environments, and building resiliency into those systems as much as you can do. So we're going to have that resiliency there. Now, where I'm working nested, we'll see as we build them out, is obviously not like that. We're just going to go, here's a blob of storage, but obviously, you're just building that with a hardware RAID adapter from whatever box you're building, if it's hardware RAID. Now, from a networking perspective, we can do something like this, where we can do NIC teaming, and we're going to do NIC teaming as part of this build process on the front at the very least, but obviously you could also do it on the back for the virtual networking. What I'm going to build as part of this lab is some back-to-back cabling, as it were, so some DAC cables between the systems themselves to be able to demonstrate the NIC team, but also then the independent vSwitches, the independent IP subnets that we'll utilize on that storage side. So let's get started. Let's pull up this first. And as you can see, we're going to go with a nested environment. As we can see, by logging into this system, this is a great big VMware environment, but what I have then is my folder where I can see my virtual machines, and I'm going to create my VMs to then be nested on top of VMware, but running Hyper-V, just for ease of deployment and showing you quite how this stuff works. Essentially, so MC-Hyper-V 1. Let's go with that, shall we? Okay, next. Typical. I've already created something with that name. Where are we? Here he is. I'm going to delete that guy and we'll start afresh, just so that you guys see everything end to end. There's row 1. Don't really care where it runs, and we can put it on some NVMe storage just in the hopes that things go relatively quickly. Now, I'm going to select the newish version of Windows. I'm actually going to grab the pre-release of 2025. I'm going to do a number of CPUs. And the key piece of doing nested virtualization is we need to expose the hardware-assisted virtualization to the guest OS. I'm going to give myself, say, 24 gig of memory, and I'm going to have a 240 gig boot. Now, that's just typical for what we use with both VMware and Windows. It's not big in the modern world. But what we can also do where I'm working nested, just to be a little bit cheeky, is then provision it. So in addition to that, I'm going to have then my shared storage, as it were, and I'm going to be, again, working in this nice little small environment. So I'm going to do a 10 gig cache and a 100 gig capacity tier, as it were, just have some nice round numbers for that SvSAN storage, effectively. What I'm then going to do is have a front-end management connection. We're going to add an additional NIC on that same front-end management connection. And then I'm going to add a couple of storage NICs. And you'll notice here with the port groups that we're attaching to that each of these is an independent VLAN, as it were, a separate subnet. Okay. So with this, we're sort of working with typically a 4-NIC system. We've got these two teams for our external traffic and these two DAC cables that we're going to do for our infrastructure live migrate to Failover as well. So if I grab my ISO storage, we can find Microsoft. We have all our Microsoft ISOs, and we can find then 2025 pre-release. Exactly that. Okay. So the final step in creating this netted VM that I'm going to do is to add a quick advanced configuration parameter that you can find in VMware. And that's this. And what it does is it makes those VMDKs be seen as SCSI disks, effectively. Now, having provisioned that guy out, again, benefit of working nested, I can then clone that to a Hyper-V O2 and keep it nice and easy as well. So that's that guy there. We can put you on there. We can sim provision all of that as well. I'll wait for that guy to complete. And at that point, we can then power these guys on and start our installs. There's that guy. Catch the ISO. There we go. Cool. But I'm going to do it with the desktop just to make things nice and easy. Sign your soul away with the license agreements as per usual. Standard desktop. Next. Accept. And obviously we can then see these different disks that we've provisioned now. Okay, so I'm going to install to the 240 gig. Now here we go. Okay, so we're all up, and we can punch in our local admin password. Okay, so I have one system up. Let's get the other one for the same point so that I'm not going too far ahead on some different things. Now, a lot of the steps that we're going to do here can actually be done in a variety of order. Now, again, for diligence and making sure that you're catching each one. It's absolutely fine to go through these. Now, what I'm also going to do, just where I'm working in VMware to make my life a bit easier, let's install VMware tools. There's the console stuff, and we can also come in here. I'm just going to set my host names. So MC-Hyper-V-01. There. Leave those as is for now. Pull that one there. From there, but I'm going to skip you and now do our VMware tools. We go. Next. And then bounce for our restart. So our next piece I'd propose is to add the roles that we're going to be using to get the clustering stuff up and running. There we go. And key Windows features are then going to be Hyper-V. And on the next screen, then failover clustering, and scrolling down slightly, multipath IO. Let's skip the vSwitch creation because we'll do that manually after the fact, and then we can restart if needed. It's fine, and install. And then the same thing over here. So once again, Hyper-V. And failover clustering and multipath IO. So being a hyper-converged system, obviously what we're looking at is compute, storage, and networking. So once this guy's up and just logged in, and this guy's finishing off doing its stuff there, let's check on the storage piece first. Okay. So within Disk Manager, in order to provide the storage to the SvSAN VSA, we want it offline to the hypervisor. We don't want Windows to be touching it at all. So exactly as this, it can be online, it can be initialized, but we can see that we want them in this offline, unformatted state. Okay, so that's perfect. Next up then is we're going to take a look at the networking. And forgive me, I'm going to do a control panel as opposed to the trusty settings stuff. What we can do in here then is take a look at our different NICs and our different interfaces. Now, if I just grab the details, what I'm going to do then is to take a look at each of these. Now, I've got this fairly nicely, having configured it in VMware. You can see my internet access on each of these, and what I can actually do is, even a rename on these guys to make them friendly names. Okay. Management 0, management 1, SCSI 1, SCSI 2, or SvSAN 2, or anything else that you want to call them as well. Now, in my case, I'm going to set some statics on these guys. Let's do my management first, forgive me, and let's just catch this guy up as well, so that we're on the same page, because the networking really is fundamental, and you want to make sure that you've got the networking right before you start to layer everything else on top, as it were. So, cool, all completed there, very nice. C then drives offline. All very good. And here then. So network and sharing center. Here, let's grab some of those details. And we can see quite easily once again. Which one which. Obviously, what you can do if you're not sure is check MAC addresses. With a status within here, you can get the details and you can see the MAC address of the connection 4880. We can see here if I come into VMware, because again, it's nice and easy. .4880, and obviously it can be done via command line with an ipconfig ipconfig/all, and you'll be able to get that same sort of MAC address detail. So what I'm going to do next then is to follow some documentation. You can find out about this stuff on anywhere on the web as well, but we've got some internally within our own sort of portal. And I'm going to team these NICs together. Right? So this is a concept of getting your network cards both or multiple attached, so that should a cable come unplugged, that it'll fail over to another NIC. Now, within, I think it was 2012, 2016, Microsoft had this concept of LBFO, load balancing and failover. Their newer approach with 2019, 2022, 2025 is this set switch embedded teaming. And this is configurable via PowerShell commands. So not configurable via Server Manager, but by Windows Admin Center or this thing here. So I'm going to then come along and copy this, because I'm after working on console, let's just put this out here as an example. So I'm going to have to hand type this. We can call it that. That's as good as anything. And we're going to go mgmt0 in the quotes. mgmt1 from where I've just re-enabled them. So embedded teaming true, and in this case, I'm also looking to use SRIOV as well. Okay, so if I do a cd / so we get a bit more space. And obviously you can tab complete these things as well. Okay, so finish name, and again, call them what you will. But the thing with clustering is that they need to be the same name that the VMs are attached to on both sides. So it's certainly recommended to keep the naming consistent between the both nodes. Okay. T0, MGOT1. Enable embedded $true, if I could type. And in my case, enable IOV as well. Now, that's interesting. That's what happens when you typo stuff. Give it one more go, and we'll do a new VM switch rather than a net one. And we'll see that come along and create. So now, within my network adapters view, we can see this guy here. What I'm then going to do is to configure myself up a static IP address on this. So I'm 10.10.130, and I'm going to use 51 for node 1, 52 for node 2, 53 for VSA 1, 54 for VSA 2. Nice and simple. And 0.1. So I've got a DNS, I've got a gateway, and I've got some connectivity. So now coming into Hyper-V Manager, we can configure up the vSwitches on top of iSCSI 1 and iSCSI 2. So we can see the one that we've provisioned there via PowerShell, and we can configure up iSCSI 1, and again, create an additional one, iSCSI 2. But what I need to make sure of is that I'm selecting the right NIC. Now we can see here a device name, connection, and number 2. So I want to ensure that I have the right one on each one. So this guy is on the right one. This guy I need to come along and change to number 2. And we apply that, and we can OK that. And actually, after all of my comments, we can see that that's now grayed out. I'm going to remove those and recreate them with SRIOV as well, just to make sure that I'm getting the maximum performance that I can get from those connections. So enabling that SRIOV, number 2, and we can apply that. I go yes. Okay. And then I can come along and configure up some statics on those as well. Now, obviously, being in theory cabled, they're not going to have any DHCP or anything like that on them. So there we go. We can go with that there, and we can go with this here. Now I'm using these IPs because of the environment that I'm working in, 192.168.130.51. But obviously you could use whatever is in our example IP schemas or whatever your environment is looking to utilize. So let's just repeat that workflow on this side as well. So if we go to PowerShell, oops, my Windows presses don't work in the same way when I'm working in the console. Should have thought about that. And then we can repeat our set VM create. Okay, so new -VM switch. There we go. Switch, yeah. And dash name. Set dash VM switch. Adapter name. GMT 0 and GMT 1. Enable embedded main $true. I should enable IOV $. So once again, then this is just our knowledge base. Obviously, support.stormagic.com, come in and you can search documentation, teaming, and find the relevant page that I was following to create those NICs. So once again, then let's go Hyper-V Manager, and we'll create those additional storage vSwitches. Oops, I did them lowercase on one side tonight, so let's keep them lowercase this side because it is case sensitive. iSCSI 2, and once again, then in here we have a look-see and just check our whoops. So I want 2 and 3 on this side. So also note there. Now I've done this exactly the same. I've cloned the machine, and note that those device numbers are not the same between the two systems. So do just be very cautious and very diligent about what you're checking there. So I want iSCSI 1 on NIC 2, and iSCSI 2 on NIC 3. Okay, and we can apply those, and then we can set our static IP addresses. Okay, so once again, I'm going to set my static IPs, 30.52. And note that those back-to-back don't have any kind of a gateway because they're only routing to each other. They're only routing within that IP subnet. So next thing, sort of a good thing to check, is that we can then ping between. And that's all looking fairly positive. So excellent stuff. So what we're going to do next is to enable our MPIO. Now, as we know, SvSAN is presenting of a block storage device over iSCSI. So what we do is we come into our start menu, having enabled the multipath feature, and we type MPIO, and this opens up this interface. We go discover multipaths, add support for iSCSI devices. Easy as that. And okay, and we need to make sure that we do that on both systems once again. Okay, so MPIO, discover multipath, add support for iSCSI devices, add. Okay. So what we've done is effectively create these VMs, just to summarize. We've installed Windows. We've checked that the storage is in the state that we want it to be, i.e. we've got our OS disk, and then we've got our offline disks for the SAN. Then we have set up our networking. We've teamed 2 for the front end and configured some static IPs, and we've then got the equivalent of some DAC cables, and they've each got vSwitches on top. So the next piece that I want to do is just join these to the domain that I'm using, and then we can deploy SvSAN. So here I'm just in a work group. We're going to change this, and we're going to go ps.stormagic.com because that's the domain I'm working in. Nice and simple. One. ab.ts.stormagic.com. There we go. We go administrator. I can't type. It's looking promising there, and obviously that's going to need a host restart. So we'll do that one more time. So once again, server manager, and join to the domain. Okay, so we've done the sort of base config. What we'll now do is to pull down the package and install SvSAN. Sure. Just give me a browser. Here we go. Right, so support.stormagic.com. And as I referenced then, anybody can come in here and with the sign in and create an account, sign up, enter your email address, and create someone account in here. Now, in my example, I'm going to log in. And because it's going to take me in as agent. I'm going to just need to do my 2FA. Now, end users don't need to do this. This is just for internals. Now, under the download section here on the left-hand side, we can left click and we can find our different packages. Now, SvSAN, and what we're interested in then, if we do see all 10 articles in this instance, is our Windows installation package. Now, this is the same package for SvSAN as it is also for the witness when running on Windows as well, for our witness service. Okay, so I'm going to do this and just pull that guy down. Perfect stuff. And with any luck, depending on firewall rules, now, I'm 30.52. Can I do that? Yeah, look at that. I can also then just paste that straight across to save me downloading it twice. So we can even extract over the wire on the other system. Fine, we'll then have to run that over there. But we're then going to have a look at my downloads here and extract here. And we're going to run our StorMagic installer with admin rights. So you can see we've got the smart screen stuff. You can select more info and say run anyway. And then we can come along and sign your soul away. And this is going to check the different versions and such of Windows that are running so that we can then deploy. Now I'm going to do a custom install just so as I can see the different packages. Now you can see StorMagic Witness Service is not checked because it has detected that the Hyper-V role is running on this computer. So if you do want it, you want to force it, you can obviously check to install that service as well. But the bits that I need to deploy my VSAs are these two Hyper-V deploy wizard and installer service. So I'm just going to kick that there, and then we'll do the same on the other bots as well. Okay. Once again, no witness service, next, and install. Okay. So everybody knows the witness has to live off the two clusters, two nodes. The cluster itself has to be separate. So hence that service not running there. But maybe you've got another Hyper-V box somewhere else that you do want to use as a witness service, for example. Okay, so now we want to do our deploy wizard. So if I left click here then, this will basically provide a step-by-step process to be able to build that VSA. Now it's just a VM. You could build it manually. There are ways and means, but it just makes your life a little bit simpler, for example. So I'm going to punch in my credentials to be able to deploy the VSA here and authenticate to the host. Now I'm just going to bring up a comment because it caught out one of my friends in another company. Proxy settings. What this is doing is a loopback IP connection. So just bear in mind your proxy settings in your web browser. If it can't then resolve itself and it's trying to go external and root elsewhere or whatever else, it might not be able to resolve or it might not be able to connect. Okay, so take a look at your proxy settings if you're having issues getting through that step there. As you can see, to do a domain, you can just do a domain backslash, or you could do your local admin. You do a dot backslash as your local admin, for example, there as well. Okay, but if it's not able to establish that connection, take a look at your proxy settings. Okay. Sign your soul away with a trusty StorMagic license agreement, and we can see here then the default path that it's going to deploy that appliance to. And I'm going to slurp up. We can see those two offline disks available. I'm going to grab up my capacity disk here to create that pool on top of. We can then, because I've done all that legwork previously and configured up those vSwitches, define out my VSA IP addressing. So 10.10.30.53. And we're going to come in here, 10.130.254. And we're going to do 10.200.0.1. We're going to locate that, and then these guys here, just try and do it logically and do one first. 192.167.130.53, and then 192.168.130.53. Now then, if we just go back one step here, we can see what will be the hostname of the VSA, and it's just a pending VSA in front of that Hyper-V hostname. Now, I'm just going to make sure that that is resolvable ahead of deployment. What it's going to do, that one maybe. All right, here we go. They've connected. What it's going to do is to push that image, boot it up, and then make sure that it can chat to that. And it's going to try and chat to it via its hostname to make sure that it's deployed successfully. So I'm actually just going to come in here, 10.7.30.53, make sure I don't have any duplicate records. And I'm going to add records for my VSA. So MC VSA, MC. Oh no, my apologies. See, VSA MC-Hyper-V01, like so. Is that what it's done? MC dash, no, it's got my dash on that 01 as well. 110.30.53. Save that one, and we can add. Okay, edit that. VSA MC, save that. Go to 30.54. Save that and apply those changes. Now then, in order to check those, what we can do here is we do love a bit of DNS. It's IP config space flush DNS. And even though it's not there yet, MC-Hyper-V-01 .tns.com, we can see that we get the right IP address back, even though we're not getting a response from it. So it's still able to then resolve the name, and we know we're in a good spot. Okay. So there we can see our pass-through disk, we can see our IPs that we've set up, and we've got our storage, our synchronization traffic flowing over those back-to-backs. And then we can punch in some license keys, just find some license keys. Now, for licensing, just to explain, while I'm waiting for certain things to happen on the other screen, what that appliance is going to do is try and root out the licensing.stormagic.com. Now, you could absolutely just skip this step, and it would then try and resolve, fail. It wouldn't license. You just license post-deployment. It would still complete the deployment, but you can then sort of effectively proceed even if you're not licensing or whatever else. Now, I'm going to do one via the wizard here, and then I'm going to show you that with VSA2, because what you can also do is an offline license file if you need to, if you're in a closed environment, for example. That looks good. Now, give this guy a password. And there's that host name that we saw. Obviously, if we had something else, a slightly different setup to VS, it's just the host name. Call it what you like, effectively. Next and finish. Okay. So what we can do is actually see this thing start to build out and appear in Hyper-V Manager. Now, that has obviously all finished there. Cool. Now we could do the same build process on this machine, which is that loopback connection. Just know there's that guy building out. What you can also do is actually push from a remote machine. So if we run as administrator here of another instance, we can select the other node and push to that remote Hyper-V system. See this guy coming up? Maybe not. Is that file related? What's going on there? It's nice to be able to see that. It should be allowed through. It should be. Let's just be really lazy for now. So I'd be curious to see that connect. So that's doing stuff. That's that deploying. And then go in there. One more time. There you go. Okay. Firewall related file. So number 200 gig. Yes, please. And then our management IP addresses. 10.10.30.54 in my trusty schema that I got going on here. And then 130.254. And then 10.200.0.1. Okay, so we can OK that. iSCSI 1, 192.167.130.54. 54, let's get that right. And finally then 192.168.30.54. Nice. Okay. Next, so I'm going to skip that license key and we're going to license after the fact with offline license file. Next, finish. So within our Hyper-V Manager here, we should also now be able to connect to MC-Hyper-V O2. And once again, we'll be able to see that second VSA doing build process. So this one has completed all successfully. We can close that out and we can close that out. And we can see this guy just doing its stuff here, there in the background as he starts to build as well. So the actual VHD, just while we're waiting for that to do its thing, isn't all that big. We put it, where do we put it? Program files, StorMagic, SvSAN here. There should be a zip file, 216 megabytes. So obviously, if you are pushing to a remote host that's over the WAN, just bear in mind it'll be pushing about 200 megabytes of data out to that remote host. So nothing huge, certainly doable for a remote host, but it is, 200 megs that's going to be dependent upon that WAN link as to how quickly this thing goes, effectively. So while we're waiting for that one, notice that the wizard only gave me the option to map up one drive. Now we also have a cache disk, so I want to then select my SCSI controller, add a hard drive, and I'm going to add up, or map up, and up that additional 10 gig disk post deployment. And I could do that with as many disks as I like if I was doing a software RAID over individual drives to an HBA, for example. There we go. So that has completed successfully, but note that we don't have a license key on this guy. Okay. So what we can now do is from our individual node is come along and open up our VSAs. So 53, 64. So default password, if you set them up manually at any point or OVA or anything like that, it's just admin and password. Obviously, if it's not that, then it's the password that you've then defined. Okay. So what we're now going to do is license this guy up. Okay, where I'm doing the offline licensing. So we're going to go licensing.stormagic.com There's a web page from our client that does then have access. I'm going to download an offline license file, and I'm going to punch in my key. And I'm going to take the appliance serial number. I'm going to submit that, and that's going to pull down a little 4 kilobyte odd license file, effectively. Did that do it? I didn't click that. My fault. Fine. So if we now click here, we can see either we can punch in a license key for an online activation, or in my case, as I'm doing is here with this downloads, push up the offline license file, and bing, it's all licensed. So what I didn't do to this guy is to map up that additional 10 gig. So we're going to go add a hard disk, and we're going to map up that additional 10 gig as our cache pool. And I'm going to have to do a couple of manual steps here. I'm going to zoom out to get me a bit more screen space. So I've got my 100 gig pool. Because I'm looking to do caching, I'm going to need to create my cache pool. And then my cache store on that cache pool in a minute as well. Now, let's zoom out a little bit here as well. We've got pool, we go create, here we go, cache 0, JBOD, yes, please create. Now, the other downside of doing the caching, and I'm intentionally making my life difficult here a little bit to show you the more manual steps with a Hyper-V, this is all done nicely for you in VMware, is that we need a little bit more memory on the VSA. So I'm actually going to shut down the appliance because I can't hot change memory. If you take a look here, we can't. 4096, maybe I can. There you go, didn't think I could. So if we shut down here, again, Hyper-V limitation that we can't hot change it because of virtual machine memory versions or whatever else. I'm going to map up a little bit more memory, quite a lot more memory in that instance. It's 4 times the amount, but you get the idea. And then we can come along and do all of our memory-based and SSD read-write cache as well. So we can go settings here once more and crank that up to 4096 and apply that and start back up. So essentially we're getting there. We want to come to iSCSI initiator, go yes. And we're going to need to come over this side here and bring up our iSCSI initiator here as well and start the service. And let's just make sure that our firewalls are all back on as they should be. And what we're now going to do within the iSCSI is to punch in our addresses. So 130.3 of the appliance IP addresses. So it's not going to be able to do anything. It's not going to be able to connect right now, but what this is doing is making the box go out and try and connect. And you'll see why I'm doing that in just a second. We can apply that. We propose. You can come in here, discovery. Now, with that thing having started back up again, if I just accept that, we can now see, go to that one. Our initiators will now have populated in here. This would have been blank before, but because that host has gone out and scanned and said, hey, what's out there? What can I log into? We now see it populated up. And what that means is that we can first create our cache stores. So I'm going to come in here and I'm going to create my cache. Oh, well, that's difficult. Fine. It has to be at least 16 gig. I've done it nice and small. I can cancel that or skip that bit, but you get the idea. You can literally create your cache store and then you're enabling it on the target. Let's create a memory cache. Then we can definitely do that. Create memory cache. And over on this guy, because the cache is local to each system, we're going to create our memory cache here. And then we can provision out our targets. So I'm going to create then a witness disk for the failover cluster, and I'm going to give it 1 gig. And we're going to go mirroring, and we're going to go caching. And we're over to VSA2, and yes, we want to go to that 100 gig. So you get the idea there. And we're using, in my instance, a Lenovo witness that's going to grab. So that's provisioning a target. Now I did that very quickly. So let's go through one more time. We're going to create. And now I'm going to create the CSVFS, the data store where those virtual machines are going to live. And I'm going to create it on my backing store, my big pool. I'm going to use all of the capacity now because I've used the 1 gig that I want to use. I just want one blob of storage. Here I can configure up chat authentication if I'm looking to do that. I can then select the initiators that are allowed to log in. I can select mirroring and I can select caching. And again, with that witness, we can see we're grabbing a witness that we have available. And this will be displayed within here as far as available options as witnesses. Okay, this is our discovery service. They'll automatically pick each other up within the same subnet. But if you need to add static entries to a different witness, you can do that here. If that witness is in another data center or somewhere else, you just add static entries effectively. And then we can create that guy as well. Now, these guys will then start synchronizing there in the background. Now, if I just mouse over this blue resynchronizing, now again, where I'm working nested and I thin provision everything, do bear with it a little bit, but you get a speed of that synchronization and you get a time for it to complete, as it were. So that's going to complete in 3-4 minutes time, about 300 megabytes per second. Fastest I've seen that running at is about 2.5-3 gigabytes per second of that initial synchronization. Okay. So that's everything done SvSAN side. We've deployed the VSAs, we've wrapped up the storage, we've created the additional cache pieces that I did a bad job of, but we've got them there, and we've provisioned out our targets. So now what we want to do is actually log into those disks with the hosts, and with a quick refresh here, we'll now see them populate up. Okay. And I can do the same, and we'll need to do the same on this side as well. Now, what we also want to do is to make sure that we're logging in to everything as we should do. Okay, so this is where, again, that bit of diligence comes in. And you can script this. We've got, just to give another example, some scripting of the logins available. PowerShell. Should we do somewhere? There is somewhere in here. I can't see it. Logging into the targets anyway. But what I'm going to do is then try and be really diligent and step my way through. So what I'm going to hit first is connect. I'm going to select my multipath. I'm going to go to advanced. I'm going to select my local initiator. I'm going to select my local initiator IP. And I'm going to go to 53 on the 167 subnet first. And then, once again, those same things this side. 54 on the 167 subnet first. So I've now got a session to each VSA on that 167 subnet to that target. And I'll be able to see that with the witness disk 1 here. And again here, as the witness disk here then has that one session. You can also see which initiator that's coming from. For example, here as Hyper-V1. Okay. But I'm now going to repeat that for the other subnet. So I get all of my paths as I want them to. So the 168 to 168.53. And then same thing. 168.54. And that's that logged in from this host, that being that target logged in from this host to all the sessions. So I want to repeat that for the CSV, and then I need to repeat it for both targets for host 2. Now, we do have a tool coming imminently that's going to ease the process and do all of this login stuff for you. But for the meantime, that bit of diligence and just step your way through, make sure you've got all your sessions as you need them and want them, so that it's all nice and tidy as far as login. But I think this appeals to my anal retentive side. There we go. 168.53 and then 168.54. And when you can OK that, and we can see that we've then got 2 sessions, one on each subnet from Hyper-V1. I now need to go over to Hyper-V2 and repeat those same steps. So 167.53. And this is where this is a little bit more complicated, where I have the back cables and the 2 IP subnets. Obviously, if they are switched, then it's a bit simpler because you could just have a single storage subnet. So you'd just be doing the connections one each side, each host to each VSA, as it were. So half the work. I want that one. That one. And obviously, if you select the wrong one that it can't route to, it'll fail to connect as well. So just bear that in mind. Yeah, 54. One target to go. 53. 167. 54. Is it 8, 53? And then 168, 54. Okay. Now, just because I find it easier to sort of try and focus working on one system, we can now come in and take a look at our disk manager one more time, and we'll be able to see those StorMagic presented disks available. Okay. Now, if MPIO isn't configured correctly, you would see the 1 gig disk 4 times and 100 gig disk 4 times, so on. Okay. So just make sure that that MPIO is there and configured as it should be. So I'm going to put a file system down on each of these. Now, it's not a CSVFS yet. I've called it CSVFS, but you can see it's an NTFS, or if you're using REFS underneath, then it would be an REFS. The next thing to do then, or the final step, as it were, is to configure them into a failover cluster. So as we come up here, we'll be able to create a cluster. C-Hyper-V-01. So then we don't let me type things, check names. C-Hyper-V-02. Nice. And we can do a cluster validation. Now, this is going to do a bunch of those checks that make sure that it's seeing all the paths to the storage correctly, and that those vSwitches named correctly, and that they're chatting correctly, and things like this. So this is definitely worth doing, just to make sure that everything, you haven't missed any steps and things are nice and tidy. It's just finishing up. So testing is completed. With the test you selected, you should review some warnings. Okay. So have a quick look at that, and we can see that we've got a warning on networking, validate switch embedded teaming. RDMA technology type. Okay, I'm working listed on VMware, so not such a surprise, but do bear that in mind that you might see some different things. Okay, you get the idea there. Finish. MC dash cluster. And let's put you on 55 as an IP that I'm not using. This is the virtual IP address for the failover cluster. I'm not going to add my storage because I'm going to do that manually myself. And then it's going to go ahead and join these two things together. So having created the cluster, we can come into storage, look at disks, and because I unchecked that box, there's nothing here. So I'm going to manually do that piece, which is my 1 gig and my 99 gig that I provisioned as my shared disks. Okay. So within here, we can see the size, we can right click, and I'm going to go add to a cluster shared volume. So that becomes effectively my shared storage, my data store. I'm also going to come along and right click my cluster. I'm going to go to more actions and configure cluster quorum settings. Now it's up to you as to how you configure the cluster quorum in a 2-node. You can either have multiple Hyper-Vs, i.e. a third Hyper-V host, or obviously they offer the ability to do a disk witness, a file share witness. Now, I'm trying to do as minimal a footprint as possible, so I've got the disk witness on top of SvSAN. But in all honesty, I've also got a Windows box that's running my SvSAN witness service, so I could just as easily do a file share witness over there if I chose. But either way, cluster quorum stuff, we've got some documentation on it, take a look. Most of our customers will do a disk witness or a file share witness, but up to you. So here we can see I'm selecting that 1 gig to be my disk witness, and away I go. We can see my different networks. And finally then, we can create a virtual machine. So I'm going to go virtual machine, new VM, next. Let's put it on 1. I'm not going to put it on the C drive because then it's not going to be on the shared storage. I have to put it in my CSV. So I'm going to browse the file system, C drive. We now see cluster storage, CSV volume 1, and I'm going to create a I also tend to do, just as a FYI, is split out. But again, personal preference. Put it in that virtual machines folder. Don't like that. That's fine. We create a VM. We're going to go, I don't know, 124 because it's nice and small when I'm on nested systems. We're going to put this on my set VM switch. I'm going to go 20 gig. I'm going to skip an OS and I'm going to go finish. And this VM then is on the shared storage. It's configured for high availability, and we could start it up and install it. We can also then select the move and live migrate it over to host 2. And over it's gone. And then if we just make sure that our SvSAN stuff is all good, we can also do, and again, benefits of working nested, we can now power this guy off and wait for our VM to fail over the host 1. Okay. And there we can see the VM up and running again on host 1, despite that Hyper-V 2 is all powered off. So that was an end-to-end build of Hyper-V, 2-node Hyper-V cluster with SvSAN shared storage. Just power this guy back on and it'll be sort of automatically powering on, resynchronizing, and ready to tolerate further failures. Thanks for watching. I hope the video is helpful, and any issues or questions, you come to us at support.stormagic.com and I'm happy to help. Thank you so much.